It strikes without warning, unleashing the force of 300 atomic bombs.
It all happened in a flash of an eye.
To witnesses, it's Armageddon.
They were thinking this is the end of the world.
It's a mystery that baffles scientists. Could it be an asteroid, volcanic eruption, alien intervention, or a radical new theory from particle physics? All agree we need to find out before it happens again.
This is like a crime scene.
A team of investigators races to solve the puzzle of the largest natural explosion in modern history. "7:18 a.m., San Francisco, California. The city stirs awake. Downtown looks like any other day. Then, everything changes. An ear-splitting boom echoes off the skyscrapers, followed by a blinding flash. A superheated shockwave tears through the entire Bay Area. In just seconds, it transforms the city into cinder and twisted metal. And yet, there's no impact crater. Could a blast this devastating really come out of thin air? One thing is certain: it's happened before. It's 1908 in central Siberia. An explosion uproots 60 million trees and devastates more than 800 square miles of the countryside. An observatory 600 miles to the south registers seismic shocks equivalent to a magnitude 5.0 earthquake. Instruments throughout Europe and Asia record bizarre readings. And an eerie afterglow lights up the night skies around the globe. It's known as the Tunguska event. It remains one of the greatest mysteries on Earth. Almost from the start, scientists think that the Tunguska event is an asteroid or meteor strike. That long-standing theory explains the power of the explosion, but it fails to account for the lack of evidence of an impact. In Tunguska, there's no massive crater and no credible discoveries of meteor fragments. A more recent theory says the explosion could come from inside the Earth, a freak eruption of volcanic gas. A more radical theory from experts in particle physics says it could be a collision with a substance called mirror matter. And these aren't the only popular theories. Some Russian scientists are certain that UFOs caused the Siberian explosion. But all the theories remain unproven to this day. The only way to solve the mystery is to gather physical evidence from the site. And that means trekking to Tunguska, Siberia. An elite group of geologists, physicists, and astronomers sets out for the explosion's epicenter. This expedition offers the rare chance to investigate a mystery that has baffled everyone else. They've put together the most comprehensive team ever. Each brings his own expertise, and each plans to prove his case.
In a way, this is like a crime scene. And everybody likes to investigate a crime scene. You know, there was a big explosion, it left evidence, what happened. And the more evidence we can gather, the more we can nail down the details of the event.
And just like crime scene investigators, they're combing Tunguska for clues.
If this was from a natural burn, from the flash, it wouldn't stop here. It would continue on up, don't you think?
That's right, yeah. That tree got ripped apart right in here by the force of that blast. It's just it's just mind-boggling what could do that.
Cornell University professor Jason Phipps Morgan believes the answer lies beneath their feet. He's searching for evidence of a volcanic event he calls the Vern Shot. 250 million years ago, an outpouring of lava covered this section of Siberia. Phipps Morgan thinks that massive pockets of pressurized volcanic gas trapped in bedrock burst out so violently they explode into the atmosphere. He's inspecting the native rocks for signs of this upheaval.
In my view, there's a real possibility that the Earth is capable of much more explosive activity than anything that we have seen in human history.
Ginter Kletechka is a PhD geophysicist at Catholic University. He's investigating a radical new theory about the existence of mirror matter. In theoretical physics, ordinary matter accounts for only half of all mass in the universe. Kletechka believes that the other half is made of mirror matter that exists in a different dimension invisible to the human eye. We can only detect it through its gravitational pull or when it slams into the Earth.
So now we have this mirror matter, and we think that it may be in our solar system, and maybe it could be on a collision course with the Earth.
Kletechka thinks the blast at Tunguska could have resulted from a mirror matter object striking Earth's atmosphere. If so, there should be traces of a magnetic surge. Kletechka is searching for a unique magnetic signature in the oldest trees left standing at the epicenter. Physicist Mark Boslow from Sandia National Laboratories believes that an ordinary matter asteroid was the culprit, but that it exploded in the atmosphere and never reached the ground. This is called the airburst theory, and he's one of the world's top experts.
Well, I'm interested in Tunguska because it's the only unambiguous example of a low-altitude airburst on Earth.
In his scenario, an asteroid streaks toward Earth at 9 miles per second, plows into the atmosphere, reaches its breaking point, and explodes. The heat and shock waves drive toward the surface and flatten everything in their path. But can Boslow find proof of an asteroid airburst at Tunguska? Or was it a volcanic eruption, mirror matter, or even alien intervention? If Boslow is right, an airburst would produce a fireball of vaporized asteroid, hundreds of times more powerful than the first atom bomb. Tunguska, Siberia. The most violent natural explosion in recent history destroys more than 800 square miles of forest. Over a century later, a team of investigators travels halfway around the world to the epicenter, trying to uncover what triggered the blast. They find out firsthand why few other scientists have ventured here. Covered in ice and snow for 8 months of the year, Tunguska becomes accessible only in the summer when it turns into a swampy, mosquito-infested forest. Their expedition is the most comprehensive, but not the first. In 1927, the Russian mineralogist Leonid Kulik set out to confirm his own theory. He believed a meteor or asteroid slamming into the Earth's surface caused the explosion. To prove it, he needed to find a massive crater and remnants of the asteroid. Local tribesmen called the Evinki guided him, and he interviewed witnesses.
Throughout the eyewitness zone, People heard 2021 booms. They were thinking this is the end of the world. The fur trader sees the sky spoiled, and it's so bright that he actually feels like his shirt is going to catch fire.
This rare footage, shot in the 1920s, is the only visual record of the original destruction. Charred trees at the epicenter are still standing, but for hundreds of miles around, millions of others have been knocked over, all pointing away from the blast site. Kulik came up empty-handed. He found no crater and no asteroid. But he did create the first map of the destruction. It's a puzzling pattern, almost like a butterfly. Today, no one on the expedition believes a direct asteroid hit caused the explosion. But one scientist does think an asteroid played a central role. Dr. Mark Boslow is a physicist at Sandia National Laboratories in New Mexico. He thinks an asteroid exploded in the atmosphere, causing a devastating airburst over Tunguska. Boslow examines the damage pattern in the trees to confirm his theory.
In the case of the Tunguska event, what it left behind was evidence. It left behind trees that had fallen in a radial pattern, and it wasn't just a radial pattern. They're aligned outward from what we call the epicenter, but there's also a boundary, and the boundary's got a certain symmetry that's consistent with the airburst that would be caused by an asteroid or comet exploding in the atmosphere.
But Boslow also comes to Tunguska because his theory has been challenged. In 2007, a team of Italian researchers announced the discovery of a possible asteroid impact crater. Back at his lab in New Mexico, Boslow uses one of the world's most powerful supercomputers to generate models of an asteroid airburst. So far, none result in an impact crater. His models became the gold standard because he correctly predicted the path of the Shoemaker-Levy 9 comet collision with Jupiter in 1994.
I think because we had that success, people are more inclined to take our models seriously.
Boslow thinks the Tunguska asteroid exploded roughly 5 miles above the surface. At this altitude, the force of the blast is distributed more evenly than a direct strike on the surface. But can Boslow's model exactly match the butterfly damage pattern at Tunguska? And can he explain why no one has found credible asteroid remnants at the site? In a series of scenarios, he varies the size of the asteroid and its angle of entry. Over and over, he creates models of what could happen when an asteroid hurtles toward Earth at hypersonic speed and crashes into the atmosphere. First, he tries an asteroid 120 feet in diameter and approaches at a slight angle. It explodes at 15,000 feet above ground.
It's an enormous explosion, and it creates a ball of flame that's over a mile in diameter.
This airburst matches eyewitness accounts of a huge fireball. It seems to be the right size. But in this model, the heat ignites all of the trees at the epicenter, while the rest fall in a circular pattern.
This is very different than what we now think actually happened.
He runs an impact model where the asteroid descends straight down. The explosion is too intense.
In this case, it would completely incinerate anything on the surface for a diameter of a mile or two around ground zero. Now that didn't happen at Tunguska.
Boslow adjusts the airburst model. This time with the asteroid hitting the atmosphere at a sharp angle.
In this case, I run a full three-dimensional model. I have the asteroid come in at a 35-degree angle from the horizontal.
Boslow is convinced he's found the right combination of variables for an airburst to produce the butterfly pattern of destruction. Here's what Boslow thinks happened. An asteroid screams toward Earth at over 33,000 miles per hour, barreling into the atmosphere. Air resistance heats up the asteroid and flattens it out. The air compresses so much it forms a shock wave ahead of the asteroid and a low-pressure wake behind. The closer it gets to Earth, the more the asteroid flattens and heats up until it explodes. A fireball of vaporized asteroid plummets downward.
But it stops before it gets to the surface, and it still drives this shock wave downward. Here I'm showing it in blue, and that gets to the bottom, it reflects, and it's blowing down trees.
The remnants of the asteroid are sucked into the upper atmosphere by the low-pressure wake. The sun's reflection off this asteroid dust could explain the glow in the night sky after the explosion. Boslow estimates that Tunguska's blast was equivalent to a 5 megaton explosion, which would briefly blaze many times brighter than the sun and much hotter. Only one force this powerful has ever been recorded on Earth: the atomic bomb. A 5 megaton atomic blast is equivalent to 5 million tons of TNT, or over 300 Hiroshima bombs. A pulse of thermal radiation travels at the speed of light. It's hot enough to ignite trees and wooden buildings. Survivors 5 miles from the explosion suffer third-degree burns. Seconds later, a blast wave strikes. Hitting with such force, it destroys all buildings within 3 miles and damages structures 15 miles away. Moving at close to the speed of sound, the shock wave covers 10 miles in just 50 seconds. The progression of this nuclear explosion closely matches the Tunguska blast. For Boslow, his model of an airburst seems like an open and shut case. But the Italian researchers' claim about an impact crater casts doubt on the airburst theory. So Boslow is conducting his own search at Tunguska. If he finds any trace of an impact crater, he'll have to rework his computer models and adapt his theory. Gunter Kletechka wants to prove the existence of a theoretical material called mirror matter. Jason Phipps Morgan thinks the cause was a massive release of volcanic gas. Mark Boslow believes an asteroid airburst caused the destruction. But he's not the first to bring the idea of an airburst to the popular imagination. In 1945, Russian chess master and author Alexander Kazantsev visited the Japanese city of Hiroshima shortly after it was destroyed by an atomic bomb. The aftermath he witnessed seemed strikingly similar to Tunguska. He wrote a book called The Explosion about a nuclear-powered alien craft that explodes over Tunguska, creating a deadly airburst. The idea catches fire in many imaginations and even leads to serious research.
The first time I heard about the Tunguska meteorite was in the writer Kazantsev's story called The Explosion.
Igor Zatkin is a world-renowned astronomer. During the Soviet era in the 1960s, he trekked to Tunguska. He was astounded by the destruction. Returning to his lab, he tried to recreate the scene.
We consulted with explosion and shockwave specialists, and they said that kind of pattern would not be from a single point like a nuclear bomb, but something coming in at an angle.
This rare footage captures Zatkin's experiments.
At the time, the mathematical modeling was complicated and difficult. So it was decided that we would bring the model into a natural environment. We built a big makeshift landscape with little prongs for trees. And on this vast area, we created explosions.
Zotkin was able to replicate the unique damage pattern and estimate the terrifying power of the blast.
The energy is equivalent to 10 to 20 megatons of TNT, or the power of a significant hydrogen bomb.
Zotkin surmised that it must have been an asteroid exploding in the atmosphere. And based on his calculations, if it had hit just 4 hours and 57 minutes earlier, it would have flattened St. Petersburg. Zotkin's airburst theory from the 1960s is generally consistent with Mark Boslow's supercomputer models. Key difference is that Zotkin believes the blast was about 4 times bigger.
What we're doing computationally is almost identical to what Zotkin did back in the 50s and 60s. One advantage of doing this computationally is I can change things. I can just go in and change a parameter and run the exact same simulation with that line at a different angle and see how that affects the shape of the butterfly.
At the epicenter, Dr. Boslow is looking to confirm his supercomputer models.
So here's one of these creases. It points right towards the epicenter.
Oh, that's nice.
Boslow seems to have found evidence of an airburst, deep creases on the sides of trees that were burned by the exploding asteroid.
I'm very confident that it was an airburst, but any scientist has to be open-minded and be open to new evidence. And if evidence is uncovered that suggests otherwise, well, then we'll have to rethink this.
Dr. Ginter Kletechka, a geophysicist at Catholic University, is investigating the same trees as Mark Boslow. Kletechka's theory of mirror matter adds a new twist to the Tunguska event.
There is so many ideas and so many theories proposed for Tunguska impact. I am coming from a very different point of view.
Mirror matter is a complex concept in particle physics. According to Kletechka, mirror matter accounts for half of all matter in the universe, but humans cannot see it because it exists in a parallel dimension.
So now the only difference is that this mirror matter is invisible. It has its mass, so it's controlled by the Earth's gravity, and so it's coming in, but we don't see it.
When this invisible mass collides with our dimension, it has devastating results. In his theory of the Tunguska blast, a mass of mirror matter hurtles through space. As it strikes Earth's upper atmosphere, it produces a blinding light. This invisible energy bomb heats up and generates an electrical charge that tears it apart, rupturing into an electromagnetic explosion followed by a massive shock wave that penetrates and levels everything in its path. According to Dr. Kletechka, a mirror matter blast alters the magnetic field of everything it touches and leaves behind a magnetic trace. He thinks the best place to look for the unique magnetic signature is in the trees that survived the 1908 blast.
All the wood that is younger than 1908 would have very different magnetic signature than the wood before 1908.
The growing season is so short in Siberia that 100-year-old trees look much younger. Like Boslow, he searches for burn scars, a telltale sign of the blast.
And so let me see, make sure that I'm in line.
He wants to take a series of core samples. Each ring represents a year. Since the explosion destroyed thousands of acres of forest, it's hard to find a tree that survived. Finally, a living witness to the catastrophe. It has over 108 rings, with a charred ring exactly where it should be.
So once I see this dark ring, I know that there is now sample that I can actually measure and utilize and see if the magnetism can tell me anything about this Tunguska impact.
To preserve its magnetic signature, he packs away all of the samples as quickly as possible. He'll carry them back to test in the United States. If the 1908 rings contain magnetic traces, they could prove that mirror matter exists, a revolutionary discovery about the universe. Jason Phipps Morgan is a geophysicist at Cornell University. He revels in the scientific puzzle of Tunguska.
The thing that's strange, it's really fascinating. We have records on the early seismometers that something happened. And yet, when we go here, there's nothing. It's like God is playing a trick on us. He's saying, I'm going to make you have to really work to figure this out.
He has a very different and earth-shattering theory. For Phipps Morgan, the event began 250 million years ago. An enormous upswelling of lava broke through giant fissures in the Earth's crust. For thousands of years, it poured out and spread across Siberia. When it cooled, it formed vast plains of basalt, a common volcanic rock. Phipps Morgan believes that pressurized volcanic gases built up in the lava deep beneath the surface.
The rocks are strong enough to hold the pressure, and they hold it, and they hold it, and they hold it. And then when it finally breaks, it breaks in a cataclysm.
The explosion hurtles rock into the stratosphere with the same force as an asteroid impact. This is not a volcano shooting molten lava, but a massive eruption of superheated gas and rocks. Dr. Phipps Morgan calls this phenomenon a Verne shot, as a tribute to author Jules Verne. He believes a mini Verne shot triggered the Tunguska explosion. And reflections off the ejected rock and gas in the atmosphere account for the strange glow in the sky after the event. It's a difficult theory to prove unless he can show the initial Verne shot actually occurred millions of years ago as the precursor to a mini Verne shot in 1908.
So Tunguska is the riddle on top of the mystery. If we could show that this was the site of an earlier explosion, then I'd be very confident that a good explanation for Tunguska might be sort of the earthquake and the gas release associated with a mini Verne shot.
Phipps Morgan needs to find one crucial piece of evidence, a rock called shocked quartz.
One of the key tests for the Verne shot is we should be finding shocked quartz where we had, for example, a flood basalt. So now coming here and getting the chance to try to hunt for this shocked quartz is a key part of the scientific process.
Shocked quartz forms only under extreme pressure.
We know they can be made in impacts. We know they can be made in atomic bomb tests. We know they are not made in normal volcanic eruptions, but maybe a hyper-explosive volcanic eruption can do the trick.
And now, Phipps Morgan hopes to be the first to discover it in the rubble of a Verne shot. He's looking for sandstone, since that's where shocked quartz would form. But he's searching for a sandstone needle in a haystack of basalt.
Everything that I see here is basalt. Every bit of visible rock is basalt. Yep, good old basalt.
For days, he finds nothing but basalt, no sandstone or shocked quartz.
Basalt, 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 basalt. I was in this sort of hyper alert sense, trying very hard to sort of see everything all around me, and just then hunting for this treasure of this sandstone. And Siberia was not being cooperative.
Spirits rise when a fellow geologist spots what looks like a sandstone outcropping. A small group sets off to check it out.
Being stubborn is probably a key ingredient in any scientist. Being a hopeless optimist is probably another key ingredient. And once I thought there was a chance to actually go to what should be a possible outcrop of sandstone on the riverbank, I was ecstatic that we could slog through the bog and go after it.
Finally, he spots a promising rock in a random pile.
This does not look like basalt. This might be the sandstone.
Could this ordinary-looking rock contain Fitzmorgan's holy grail of shocked quartz?
So here is the mystery sandstone that we found. You can tell it's not a basalt. It has this beautiful layering in it. And you can also see that it has a lot of the white gray crystals. This is just 60% quartz. So this will be a perfect marker for shock quartz if it's there.
Was it an asteroid bursting in the atmosphere? A massive eruption from inside the Earth? A blast caused by a mysterious force called mirror matter? Or could there be a completely different explanation, one that involves aliens? Yuri Lavbin is president of the Tunguska Space Phenomenon Organization in Krasnoyarsk, Siberia. Lavbin believes that a UFO was behind the blast. According to Lavbin, a massive meteor was heading toward Earth. Benevolent aliens saved the planet by slamming their own spaceship into it.
It started to plow towards the Earth. Here the aliens, our brothers in intellect, decided to explode that comet, to explode this mass.
Since 1994, he has organized several expeditions to the Tunguska area to search for remnants of the alien craft and meteor.
That's where the local people told us there are big blocks of the perished starship.
Lavbin found no evidence of a spaceship, but did discover these strange rocks. He collects and guards these finds at a small museum in Krasnoyarsk, Siberia. Strangest of all is one that he claims contains alien carvings.
Several rocks have markings on them that are not from any native people in the area.
It's an unorthodox claim. And for Mark Boslow, who believes an airburst caused the explosion, it's not even clear if Lavbin's found remnants of a meteor.
People often find things that look like meteorites, pieces of iron or pieces of unusual stone, and most of the time they turn out to be what they call meteor wrongs.
Do Earthlings owe aliens a debt of gratitude, as Lavbin believes? To answer yes means that Lavbin needs to prove that UFOs exist, and that they're operated by aliens willing to sacrifice themselves to save humanity. But all that Lavbin can point to are untested rocks and strange artwork. Investigators now return from Tunguska with concrete evidence to try to confirm their own theories. At Catholic University of America, Ginter Kletechka is analyzing wood core samples he took from trees alive during the explosion. If the older parts of the samples contain a unique magnetic signature, they could reveal that mirror matter collided with the atmosphere and triggered the explosion.
So what we actually found out magnetically, all these cores that you can see here are coming from one tree. These two samples are coming from outer region of the tree, and so they were grown after the Tunguska event. The other three fragments were grown before the Tunguska event. And so I found out that yes, these two samples really have a weak magnetic signature, but measurable. And then I went to these three, and I found very surprisingly that there is no difference between these three samples and these two samples.
But the lack of a magnetic signature doesn't discourage Dr. Kletechka. He's already planning a return to Tunguska in order to examine the soil and rocks for magnetic evidence of mirror matter. With his own piece of the puzzle, Jason Phipps Morgan rushes to a lab at the University of Kiel in Germany. He wants to prove a radical theory. Did the Tunguska event result from a volcanic blast he's dubbed a Vern shot? He may have found the crucial piece to prove his case if a chunk of sandstone contains shocked quartz. He sliced the sandstone in order to examine a cross-section under the microscope.
We can then actually see the individual mineral grains almost like they're like the cells of the rock. What's fascinating here is that these quartz crystals, as you can see, they have lots of little lines inside them. Based on the picture, it's really beginning to look like this may be a magic rock.
With a little chunk of shocked quartz, Phipps Morgan has found solid evidence to support his Vern shot theory.
Here you have... It really looks like we may have found a piece of evidence that is going to unlock the Tunguska mystery.
Next, he'll need to gather more samples from around the blast site to really prove his case. And he's eager to keep digging for the truth at Tunguska.
Even though it's the most bug-infested place I have ever been in, I'd go back for a month to try to sort out the geology of this area, very happily.
Hitting with the force of an atom bomb, the greatest natural disaster of recent times tears apart more than 800 square miles of Siberia. Early researchers believed that a meteor or asteroid struck the planet. But they can't find evidence of a large impact crater or meteor fragments. A century later, an expedition scours the blast's epicenter at Tunguska. Scientists have gathered clues from the trees, rocks, and layout of the blast zone. Now they need to put their evidence to the test. In Tunguska, Mark Boslow finds scarred trees that reinforce his theory that an asteroid exploded in the air. But he also visits Lake Checo, an unusual body of water that a team of Italian researchers claims is an asteroid impact crater. Back in New Mexico, he puts his new evidence to the test.
First thing I did when I got back was I came over to the University of New Mexico to consult with the experts. And they're a little bit baffled by that lake as well. They don't see any obvious way to explain it with normal geologic processes. Most of the people who specialize in impact think that it's virtually impossible for a piece of Tunguska big enough to have formed a crater the size of that lake. So in a way, we're in a quandary. It's hard to explain as an impact, but it's also hard to explain with normal geologic processes.
The only way to reconcile the two conflicting theories is to create a computer model of an airburst that also leaves an impact crater.
This is very similar to the simulation I showed before. But what I did before was I had the entire asteroid explode. Now for this, in my attempt to explain the possibility of a Checo impact crater, I only exploded 90% of it. It still explodes 2 or 3 kilometers above the surface, and in fact it creates another epicenter further towards where Checo is.
The unified model works, in simulation at least. But Boslow still thinks his original airburst theory is correct. Either way, an asteroid is responsible. The next challenge is determining the likelihood of this disaster striking again. It's such a serious concern, scientists at NASA Ames Research Center track every known object that could collide with Earth.
The Earth exists in a cosmic shooting gallery.
Asteroids are pieces of leftover rock and ice from when the planets in our solar system formed. They revolve around the Sun in a belt between Jupiter and Mars.
Most of the asteroids lead uneventful lives out in the asteroid belt, and we don't worry about them because they tend to behave themselves.
But when they bump into each other and get knocked out of orbit, some of them set out on a collision course with Earth.
The ones that come close to the Earth, the so-called near-Earth asteroids, are the ones that can hit us. And we so far know of about 5,000 that have been discovered and tracked, and we infer the presence of hundreds of thousands.
Every day, meteoroids hurl toward us, but most disintegrate in the atmosphere long before posing a serious threat. But then there are the monsters, big enough and fast enough to smash through the atmosphere and create megaton explosions on the ground. One this big would weigh 220 million pounds and could have triggered the Tunguska explosion.
We don't know really the frequency of Tunguska-like objects. It may be one every few centuries, maybe one at millennium. There could be one arriving today. The likely warning we would have on the next Tunguska is about 4 seconds. Scientists who are thinking hard about how we would actually defend against asteroids, how would we deflect an asteroid if it were headed for Earth, are just beginning that process. It's unlikely, we shouldn't worry about it at night, but in a rational world, we would think about how to protect ourselves against a cosmic catastrophe of that magnitude.
A century after the Tunguska blast, science is closing in on what really happened. A team of investigators, geologists, astronomers, and physicists has examined the blast's epicenter and brought back clues. Jason Phipps Morgan's discovery of shocked quartz offers intriguing evidence of his Verne shot, possible proof that volcanic gases produced the explosion. But today, Mark Boslow's computer models make the most complete scientific case that a huge asteroid exploded in the atmosphere, unleashing the force of 300 atomic bombs. With each piece of evidence, science comes a step closer to solving one of the greatest mysteries in recent Earth history, the Tunguska event.